today we have Mike Morris, who's a senior director for technology, strategy, and innovation at NetApp. And Mike has offered to present today on the multi-cloud DevOps platform that we currently have and that we use inside NetApp. So I'm not going to extend on my introductions here, Mike, but I'll let you introduce yourself when you're ready.
Thank you. Yeah, so thank you, everyone. It should be a good presentation today. So I'm Mike Morris. I run the automation tooling, service management, and hybrid cloud teams in NetApp IT that ultimately coalesces to create our DevOps platform called CloudOne. And I'll talk about that and go through what is CloudOne, what is DevOps to us, and then actually do a demonstration of the platform and showing how we can actually rapidly make changes to production applications. All right, so what is CloudOne to us, right? So CloudOne is a multi-cloud platform for cloud services. In this case, we're going to talk about DevOps today. We call it CloudOne because it's powered by NetApp Technologies and built by Customer One. And as Customer One, we're early adopters of NetApp technology. Customer One, we're not a dev test organization for products. We're not a QA organization. We're enterprise IT. So we use NetApp products in production to run our production applications. And that's also the case with CloudOne. We also wanted to make CloudOne the one-stop shop for all services that the cloud could offer. So everything from infrastructure as a service to containers as a service to DevOps. And I'll focus on the DevOps capabilities in CloudOne today. It delivers a one offering for private cloud and public cloud services. So in NetApp IT, if you want to take advantage of public or private cloud, we do that through CloudOne, is that one offering that coalesces all the different services that we can get from cloud providers. And it provides one consistent user interface, irrespective of the cloud destination. So that way, you don't have to deal with an AWS console and an Azure console and a private cloud interface. We do everything through the CloudOne ecosystem, and then we enable the different cloud capabilities through that single user interface. Our journey to hybrid cloud has been going on for several years now. We began the journey back in prior to 2015, where a lot of customers start, where we got around to hardware standardization and consolidation in preparation for virtualization. From that first step, we came up with our first build standards and automation, where we were automating maybe the build of VMs, or we were automating the creation of storage resources and stuff. And that led to our first cloud that we created in NetApp IT, which is an infrastructure as a service offering that utilize both public and private cloud with a self-service catalog to deliver infrastructure as a service in about 10 minutes. It was good experience, learned a lot, have about 100 applications that ran on that infrastructure as a service cloud. But we learned a lot from that. In particular, what we delivered in that infrastructure as a service cloud 4 years ago was just infrastructure landscape, VM, storage, and the appropriate network configurations. But after that, that's all we presented to the application teams. And what they were really looking for then is not only infrastructure as a service, but software capabilities on top of that infrastructure, whether that's middleware or application stacks or databases. They needed more of that software capability to gain the efficiencies and speed of cloud. That experience of our original cloud combined with industry trends around DevOps and containerization and CI/CD led to CloudOne. And CloudOne ultimately is a DevOps platform for automated app deployment. And we try to build cloud-aware applications running in containers. So microservices-based application architectures that fit nicely into containers running in cloud. We have both the private and public cloud options, as I'll show, as part of the CloudOne ecosystem. And we've gotten to a point now where we've built a continuous operating model for CloudOne, because not only have we created CloudOne, but now we have production applications running on it. So we have to maintain and improve the CloudOne ecosystem into the future. And finally, our next major milestone, which we'll hit here in about 30 days, is we're going to run what we call Tier 1 applications in production on CloudOne. So as you'll see, we have a fairly well-defined application strategy in NetApp IT. And one way we classify our applications is tiers, Tier 1 being the most important critical applications. And we've matured CloudOne to a point that at the end of October, we will now be able to run critical applications on the platform. And what CloudOne sets us up for is future capabilities from a DevOps, containerization, and cloud perspective. So expanding DevOps services, building a service mesh, and adding multiple public clouds, and then doing advanced application release models, things like canary releases and blue-green releases that speed application delivery, but bring along the protection needed to do speed without adding a lot of risk. So first of all, I want to talk about is DevOps in the enterprise and what DevOps means to NetApp IT, and then I'll see how CloudOne fits into that DevOps strategy. So there's a couple of major business trends that are impacting IT now, and those trends focus around SaaS for business apps, but DevOps for redefining your business through software. So we look at the traditional IT side, you get your run the business applications. These are things like enterprise resource planning, HR, financials, collaboration like Zoom. We're all on Zoom right now. Those applications are important to almost all enterprises and organizations, but they're not differentiating. They don't give you a competitive advantage. Your HR platform may be a great HR platform, but it's not necessarily going to differentiate you from competitors and give you competitive advantage or service your customers better. So in those type of environments, what most organizations are doing is simplifying their business processes and moving those applications to cloud, and that cloud being software as a service. Because those software as a service providers like SAP and Oracle and Office and Microsoft have already taken the time to automate common business processes. So instead of trying to build those applications yourself, it's much more efficient to go rent those applications from a SaaS provider. Much more efficient to go to SAP or Oracle and rent your HR platform instead of trying to build your own HR platform. So that's the traditional IT, the applications which are important but not differentiating. For the applications which do give you differentiation and give you competitive advantage, that's where you're trying to transform your business through software and be able to focus on customers through rapid software changes. This is where DevOps comes into play. And what you're trying to do here is rapid software development, and rapid is the key word. The ultimate point of DevOps is speed. So rapid software development using dynamic cloud services. And this is where you get the AWS clouds, the GCP, the Azures, and your private cloud. Because ultimately what you're trying to do here is create applications through DevOps that differentiate you from competitors and allow you to service your customers better. So we look at now how this fits. You've got your, I should say first, what we're ultimately trying to do, as I mentioned before, is speed and get IT to work at the speed of business. And DevOps is ultimately about speed. So in the traditional IT world, we have kind of the traditional application release model where we have our enterprise applications and there's an application release in February, and then there's another application release 30 days later in March, and then something happens in April and we don't have a release till May, and then there's the summer vacations and we can't do a release then, and then it's August. This is a very slow and risky way to deliver software changes to either your employees or your customers. Think about the time that customers or employees have to wait. They have to wait 30 days to maybe get software changes, new features, fixes to the software. Sometimes they have to wait 60 days. Plus, this is extremely risky because there is an extremely high number of changes that go into these releases. And all those different changes add a lot of risk to the release. So then several years ago, we got around to Agile IT. And Agile IT is just really a better way to organize people to work in a more efficient way. And what you can do with Agile IT is you can reduce the application release windows into something that's more agile, to use the word, or more frequent. In this case, maybe you have a 2-week sprint, and every 2 weeks you do an application release and deliver new capabilities and features to your employees or your customers. Just a better way to organize people that allowed you to go a little quicker. What we want to do with DevOps is take Agile IT practices and speed them up through cloud and automation and achieve DevOps IT. And this is where we can do application releases daily, perhaps hourly, and if we really get good at it, we'll just do it constantly. And that's where you get into your continuous integration, continuous delivery, your CD part of your application release, because you've achieved the speed and efficiency through cloud and automation of your Agile IT practices that you can constantly release new features and capabilities to your production applications. This is ultimately what we want to achieve with DevOps. So So how this works in DevOps in the enterprise now is the purpose is rapid and frequent delivery of business software capabilities through automation and cloud. So on the traditional IT side, this is where we're moving our applications which don't give us competitive advantage to SaaS. So things like HR and financials and collaboration like Zoom, we're going to just go to a SaaS provider and rent that. On the DevOps side is where we get the applications that give us competitive advantage and differentiate us from competitors. Now, these are examples I use. These aren't necessarily applications that NetApp IT runs, but what you're ultimately looking at here is the purpose of DevOps is rapid business software capability delivery. So you get DevOps as a combination of application dev and application ops. And it's getting those two different organizations who have different needs and different requirements to work in a concerted, organized way so they can deliver those rapid software changes. That's the purpose of DevOps. The challenge with DevOps, though, as it says in the subtitle there, is through automation and cloud technologies. If you do not provide DevOps teams automation and cloud, they'll have to go get it themselves. So maybe, to example here, the retail supply chain DevOps team, they go to Amazon, and the IoT app team goes to Azure. And down at the bottom, the brokerage modeling team, they built their own something in a lab because they need the automation and cloud to be successful as a DevOps team. So what we did with CloudOne is we built a DevOps platform that services the DevOps teams. So those teams can focus on their actual application creation and delivery and not have to worry about tools and automation and cloud. We're providing that as a service. We look inside the DevOps platform, we can see where NetApp fits in, and NetApp products help out and augment the platform itself. So if you look inside the DevOps platform, you see the industry products that I'm sure many of you have already heard of, everything from Docker containers to Kubernetes to CloudForms to the cloud providers themselves like Azure and AWS. NetApp products also fit into the platform, whether that's NetApp Kubernetes services or Cloud Volume services, or even a private cloud built on NetApp products like HCI and all-flash FAS. NetApp products are ultimately working in conjunction with industry products to make your DevOps platform more robust and more feature-rich that services the application DevOps teams. So before we actually go into using the platform, it's important to understand our application strategy, because ultimately what we're trying to do is decide what applications are going to SaaS and what applications give us competitive advantage and need to be built using DevOps. So in NetApp IT, we've taken the time to inventory and categorize our applications using the Gartner time model. So the time model is the applications which are tolerate, investigations which are invest, applications are migrate, and those that you want to eliminate. Tolerate applications are the applications which you'd really like to get rid of, but you can't for whatever reason. They're legacy applications that provide a critical function, and you're just going to need to tolerate them. They'll get normal little upgrades and patches, but you're not doing anything new from a business perspective with those applications. Eliminate are the applications you want to eliminate. And then the right side is where you really look to the future. So invest strategic are the applications you like and want to do more with. And then migrate are the applications which provide critical functionality, but the actual technology is old. Maybe the software is old or the infrastructure is old or whatever it is, and you need to migrate that functionality to something better. In NetApp IT, in our case, over the next 3 to 5 years, our enterprise architecture team has looked at our invest strategic and migrate portfolio and said 70% of those applications are going to move to software as a service. And the reason for that is we run enterprise IT. And most of the applications we run are the business applications. They're the SAPs, the ERPs, the HR platform. So a lot of those, instead of building those applications ourselves, we're going to go rent that from a SaaS provider. But that does leave 30% of the future portfolio, which are applications which are unique to NetApp and give NetApp a competitive advantage either through employee productivity or through customer satisfaction. Those applications we're going to need to build ourselves, and we're going to build them on CloudOne. So now we can start to see what the hybrid cloud in NetApp IT looks like. First, we have the SaaS providers, and as I've mentioned before, SaaS providers have common business processes which have already been automated and packaged by the SaaS provider. And instead of trying to build these applications ourselves, we're just going to go rent it from a SaaS provider. And that's going to be about 70% of our application portfolio. For the other 30% is where the other clouds come into play, AWS, Azure, Google Cloud, and this is what CloudOne is. CloudOne is ultimately a software-controlled and orchestrated development platform. So our developers in NetApp IT could build and run cloud-aware applications. So that's microservices-based applications running in containers. And they create those applications using DevOps and CI/CD. That's what CloudOne is. It's an application delivery platform for custom applications built using DevOps. And also, CloudOne, as being built by Customer One, is a great vehicle for product adoption. So in CloudOne today, we have our private cloud built on HCI and all-flash FAS, which I'll talk about coming up. And in the public cloud, we're using NetApp Cloud Volumes for all the storage resources. So not only are we building a cloud environment for custom application development using DevOps, but we're also exercising NetApp products in CloudOne. So what is CloudOne from an architecture perspective? Now we've defined the hybrid cloud, we looked at SaaS and the CloudOne at a high level. Now we're going to deep dive into what CloudOne is specifically. So first, the CloudOne goals, when we started this journey about 2 years ago. First thing we want to do is increase the speed of application change delivery to meet rapidly changing business needs. Again, we want to go from the traditional IT delivery model of an application release every 30 or 60 days to one where we're releasing application changes daily, hourly, or continuously. So increase the speed of application change delivery. Second, we want to make sure we focus our developers on writing code and releasing application changes, not dealing with other IT services. The reason for that is developers are a valuable resource that we want 100% of their time focused on their application, not spending maybe 25 to 30% of their time dealing with cloud and automation and tools. We want all their time focused on writing their application and releasing changes. So we want to make sure the platform provides all the tooling and automation and cloud they need. Next, create automation for frequent but small production application changes to reduce the deployment risk. So in DevOps IT, remember, we're trying to do hourly or daily or even constant changes, but we want those changes to be small so we can rapidly move them through automation and reduce the risk of each of those changes when they get to production. And then finally, we're going to reduce costs by using open source application stacks and dynamic cloud services. So build more of your applications using open source, and then when you use cloud, use it in a dynamic way that controls your costs. So those are the goals. And we had a look at where we are in a DevOps maturity model. And we say we're doing DevOps, where do we fit in a maturity model that allows us to set a baseline and then mature into the future? So this is a model we found online, and it lays out a very good model of where different organizations stand when it comes to DevOps. Level 1, ad hoc, is really not doing DevOps. If you say you're doing DevOps, but you're really doing the things, the bullets that are identified there in people, process, technology at level 1, you're really not doing DevOps. You haven't taken the first steps to do DevOps in any way. Level 2, repeatable, is where you kind of get those pockets of DevOps now. So it's not done in a coordinated end-to-end way, but maybe some infrastructure team is doing some pipeline work, and an application team is doing some containerization work, and someone else outside of IT has built some pipeline. So pockets of DevOps are going on, but nothing that's coordinated across. And then next you get to level 3, define, and this is where we are today in our DevOps maturity. And the important bullet here is in the middle under process, where it says processes automated across the software delivery lifecycle. So can you take a change to an application at the code level, submit that code change, and through automation propagate that change all the way to the production application? That's processes automated across software delivery. That's where we are today, and I'll show that coming up in the next few slides. Level 4 and level 5 are advanced levels of DevOps that we're working toward right now. So we're currently in our fiscal year 20, which ends at the end of April next calendar year, so about 6 months from now. By the end of next April, we're going to achieve continuous deployment. And really what that means is advanced application release capabilities that allow us to speed changes even more so to production. But when we do that, have protections in place in case something goes wrong. So things like canary releases and blue-green releases and automatic rollbacks of production changes that reduce the risk of deploying frequently to production. And then the level 5 is continuous operations. And this is where you get to zero downtime deployments, immutable infrastructure, chaos engineering. And we're really building applications and building a platform that never goes down. And this is where you have the born in the cloud companies operating today. So Netflix and Google and Facebook, they're running at a continuous operations level through DevOps practices. And that's why you see Netflix never goes down. Even though Netflix is constantly moving out changes to production, they have a continuous operations DevOps environment where they can speed and deliver changes to production, but it never actually causes an impact to operations. We hope to achieve level 5 DevOps capabilities in about 18 months. So now, what is CloudOne from a technical architecture perspective? There's really 3 major parts of CloudOne with ServiceNow for governance. So ServiceNow is a SaaS platform that really governs all of NetApp IT at this point. So in NetApp IT, even outside of CloudOne, we do incident management, change management, configuration management database, problem management, project and portfolio management. All these type of IT practices are automated by ServiceNow. So when we built CloudOne, we didn't want to lose that governance automation in our DevOps platform. We wanted to extend ServiceNow to also cover CloudOne. So once we have ServiceNow, then we have the 3 major components that make up CloudOne. And as I mentioned before, CloudOne is a development platform for cloud-aware applications. So the first thing we need are developer tools. In our case, our primary developer ecosystem is Azure DevOps, which is a Microsoft service. We augment Azure DevOps with the application stacks, and these are the open source application stacks that developers will use to build their applications on. So things like Spring Boot and Nginx, or databases like Mongo database, different application stacks that developers can use to build their applications on. We combine developer tools with platform software, and the platform software is where a lot of the automation exists. So since we're building cloud-aware applications, we build microservices-based applications running in Docker containers managed by OpenShift. And those applications use Helm charts to define the application architecture. We use Ansible to do automation, and we use NetApp Trident in conjunction with OpenShift to do storage provisioning. Then we combine the platform software with infrastructure as a service, because ultimately the developer tools, the platform software, and then the applications we create, those blue circles, all need hardware to run on, and the hardware comes from infrastructure as a service. And in our case, we have a private cloud built on NetApp HCI, all-flash FAS, and StorageGrid, and we use AWS. The key principle here with CloudOne is end-to-end automated DevOps workflows. Because as I mentioned before, one of the goals of CloudOne was to focus our developers on writing applications and releasing those application changes to production, not dealing with other IT services. So I don't want developers working on their application and have to stop. I've got to go into OpenShift and create a new project, and then go back to the application. They do some work and then stop. They have to go into AWS and create more VMs. We don't want them to do any of that. We want to automate all the DevOps processes across the platform so the developers can stay focused on creating their application and releasing changes to those applications. Now, as we start to look more deeper inside the architecture of CloudOne, there's 2 days to consider with CloudOne. Day 1 is where we onboard an application onto the platform. Day 1 runs once per application, and then when it's done, it will allow us to move to day 2, where the actual software development is run, and I'll show that in the next slide. What we're trying to create in day 1 is a DevOps workspace over here on the right and a DevOps host space. The DevOps workspace is the non-production part of the application. That's where developers are doing their work. They're doing source code branching, they're doing dev tests, they're testing out new features, they're doing builds, all those type of things that developers do in non-production. The host space is the environment where the application runs for real, the stage environment and then the production application environment. And then on day 2, the CI/CD process will ultimately propagate changes that developers make in the workspace into the host space. That's the CI/CD process, which I'll show in the next slide. And we also optionally allow data spaces to be created if the application needs database as a service. But to get to day 2, where we actually do the CI/CD process and make application changes, we have to run the day 1 automation to create the environment to onboard the application onto the platform. Day 1 begins with ServiceNow. As I mentioned, ServiceNow governs all the things we do. We have our self-service catalog in ServiceNow. So development teams go into ServiceNow, they select the application and what they want to do, and they begin a workflow. The first step in that workflow is we update the configuration management database, which is in ServiceNow. So all the assets we create, both physically and logical assets for an application, are all tracked in the CMDB. ServiceNow, through APIs, then hands to Red Hat Cloud Forms, which invokes Ansible automation. And Ansible has 4 major routines that it runs. First, at the top, Ansible creates a binary repository in JFrog. So we use JFrog to manage and track all the binaries that get created for the application. Next, we use an internal tool called Neat, which manages email lists for NetApp. And what we do is we create new email lists for the application, and then we assign users to those email lists from the CMDB entry for the application. And then on the back end, we use those email lists through Active Directory and Azure Active Directory to do role-based authorization in OpenShift and Azure DevOps. So that ensures we can have different types of roles as we go through the development process. And I'll show you how that is important in day 2. Next, Ansible configures OpenShift for the application, creating a project and setting quotas. And then finally, Ansible configures Azure DevOps for the application. And this is where we create the code repositories, we create branching routines, and we actually create the CI/CD process for that application. This day 1 automation concludes with a workspace and a host space being created for the application. It takes about 30 minutes to run, and it runs once per application. Once day 1 runs, now the development team can move to day 2, where the actual software development occurs. And this is where the continuous integration and continuous delivery, the CI/CD process, runs. So a couple of things to orientate you to the slide. At the top is Azure DevOps. And Azure DevOps is the primary developer ecosystem in CloudOne. It's where the developers are going to spend most of their time doing their work. In the middle is the binary creation and management environment that is part of JFrog's Artifactory. So whenever we run the CI/CD process, we're going to build binaries, and those binaries have to be tracked and managed, and that's what happens with JFrog. And then finally at the bottom is the actual application runtime environment. On this side of the slide, you'll notice that there's a light gray box right here. That's the DevOps workspace. Remember, on day 1, we created a workspace and a host space. So here's the workspace that's been created. This is the non-production part of the application. So in this case, we have containerized applications running in Docker containers, managed by OpenShift, running on AWS VMs. So in our case, the non-production part of the application, the workspace, runs in AWS. On this slide, you have the slightly larger gray box, which is the host space. And the host space is where the application runs for real, both stage and the production application. In our case, stage and production, containerized applications running in Docker containers managed by OpenShift, running on our private cloud. And our private cloud is made up of NetApp HCI and all-flash FAS. And now what the CI/CD process is going to do is, through automation, is going to take changes made by developers and ultimately deliver them to production. And how that works is up here, it starts with application source code. So some developer is working on their application at the source code level, and they're going to make changes to that source code. And at some point, they're going to commit their changes to the source code repository. When they do a commit, that commit of source code changes kicks off the automation. And what we do here is a build process where we combine the source code changes to the application with one of those open source application stacks like OpenResty or Nginx and run a build process. And that build process is going to create a binary, which ultimately will be deployed in containers, managed by OpenShift, running on AWS VMs. This build process from code commit all the way to the application starts to run in non-production in the workspace takes about 5 minutes. It's a very rapid way for developers to submit changes to their application and then very rapidly see those changes to the application running in non-production in the workspace. So developers can make a source code change, commit to the source code repository, and 5 minutes later, they can see their changes running in the application. Maybe they're making a bug fix change, maybe they're changing something in the user interface, maybe they're adding a new feature, whatever it is, they can very rapidly see the changes to that application running in non-production. Now, at some point after the developer has worked on their application in non-production, they're going to be satisfied with their changes, and they're going to submit their code change for approval. And this is the important part where different roles come into play. So we don't want just the same developer who has submitted their code change for approval also approving their code change. And this is where another role, the developer lead, comes into play. So a developer lead has to go into Azure DevOps and review the source code change and approve that change. When the developer lead approves the source code change, the first thing we actually do is we clean up the workspace. So since this is no longer needed, we actually delete the containers running in the workspace. And that frees up resources in AWS, lowering our utilization and reducing our costs in the public cloud. When the developer lead does the approval, then the CD automation begins. And this is now how we're ultimately going to propagate changes to production. When the CD process runs, it copies the binary that was created before into the stage environment. Now we pause here because we haven't automated all the advanced tests that go on in application delivery. So things like UAT testing, load and performance, integration testing are still things that need to be manually done. So we pause here and allow an application team to do any tests they need to do. There is, though, a final operations approval. So someone with the role ops logs into Azure DevOps and approves the change. When they do that final approval, then the automation starts, and the automation copies the binaries into production. And now the production application has been updated with the change the developer submitted over here. Now this whole CI/CD process from code submission all the way to production, provided the developer lead approves pretty quickly and the testing approvals are done pretty quickly, 20 minutes. Okay? It's a very efficient way to move and very rapid way to move changes to applications to production. That way, employees and customers can rapidly gain the benefits to developer changes. If we look inside day two, inside the CI/CD process of where NetApp products fit in, NetApp products support the binary management process. So JFrog manages the binaries. It's the software that manages, but the actual binaries themselves are stored on StorageGrid. And then in the application runtime environment, we leverage NetApp products heavily. In AWS, any storage request from a containerized application is captured by NetApp Trident and then provisioned on Cloud Volume Services. And in the host space, for both stage and production for the application, all assets are virtual machines are created on NetApp HCI, and all storage requests are captured by Trident and serviced by NetApp All Flash FAS. Taking a little deeper look now inside the private cloud. Again, the private cloud supports the host space where stage and production run. Our private cloud is, from a compute perspective, is built on NetApp HCI, which services VMware VMs to OpenShift, and then OpenShift deploys Docker containers inside those nodes. Any storage request, though, made by an individual Docker container is captured by NetApp Trident, and then volumes are provisioned on All Flash FAS for that storage request. And on the right-hand side there, you can see some of the hardware specifications and number of VMs that we have supporting the OpenShift environment today. As you'll see, though, that in about 2 slides, the number of VMs, it says 8 right there for OpenShift, is not a fixed number. We have an auto-scaling capability that allows us to scale VMs up and down based on demand, and I'll show that slide coming up here in a moment. Next, Cloud Volume Services. This is in the workspace environment in AWS. In this case, if anything running on AWS in a Docker container makes a storage request, in particular our database as a service, if you provision a database as a service, you immediately get a volume to support that database. All those, what's called persistent volume claim from a Docker container is captured by NetApp Trident, and then we provision the storage on NetApp Cloud Volume Services for AWS. Down here is the self-service catalog, which this is a screenshot of the demo I'll have coming up in a few minutes. But you can see as you order database as a service, when you select the type of database you want and you select the size of that database, once that automation creates the database, as you can see here in OpenShift, we have a Maria database, which is bound to a cloud volume. And so any storage request in AWS is captured by NetApp Trident and provisioned on NetApp Cloud Volume Services. And then finally, our Autoscale capability, which I mentioned about a minute or two ago. What we've done here is we've used Ansible automation to create a dynamic VM inventory environment so we can service OpenShift for whatever needs it has. On the left-hand side is we have a situation where we have increasing container demand. More containers being deployed by applications, and OpenShift is having to deploy more containers. At some point, the CPU utilization of an OpenShift node is going to rise above 65%. And at that point, OpenShift invokes Ansible automation, which builds new VMs in either AWS or our private cloud, and adds those VMs to the OpenShift cluster. So we never run out of virtualization for virtual machines to service Docker containers. On the right-hand side is the reverse case. In some situations, we have decreasing demand from Docker containers, which lowers the CPU utilization of the OpenShift cluster. In that case, once we fall below a certain threshold, OpenShift invokes Ansible automation, which evacuates all the containers from certain nodes. It removes those virtual machine nodes from the OpenShift cluster and then destroys the VMs. And this is a very efficient way to make sure we never run out of resources for our OpenShift environment, but when we don't need those resources, we're releasing those resources. In AWS, it saves a lot of money. And in the private cloud, it opens up those resources to be used in other situations. Okay. So we finish up looking at CloudOne. Did we achieve the goals that we laid out? Increase the speed of application change delivery. Yes, we can move changes from code submission to production in around 20 minutes, rapidly delivering new capabilities to end users, both customers and employees. Focus developers on writing code and releasing application changes. Yes, the principle of CloudOne is to automate DevOps processes across the entire platform. We don't want developers having to log into OpenShift or having to log into AWS. We want them focused on writing code and releasing application changes, and they do that through Azure DevOps. And then provide the automation for frequent but small production changes, and that's what we do. We tell the developers, don't make massive changes to the code base, make small changes to the code, and then allow the automation to rapidly move those changes to production. As I mentioned, we can do that in 20 minutes. And then reduce costs by using open source application stacks and dynamic cloud services. As I showed, we use a lot of open source application stacks like OpenResty and Mongo database to build our applications. And then as we flow through the CI/CD process, we clean up resources that are no longer needed, or we use the Autoscale feature to build VMs or release VMs as we need them. So a very efficient way to take advantage of cloud.
Hey, Mike, it's Mary Jo. There is a question in the chat window. It says, was fast functions as a service or serverless architectures like AWS, Fargate considered or didn't bring much value to this scenario?
So no, not in this scenario, because serverless technology is another way to build applications for custom application work. The challenge with using serverless technology from like an AWS or something like that is it locks you into those cloud providers. It removes your cloud agnostic capabilities, which you want to achieve with containerized applications. Because the nice thing about containers is that you may run them today in Amazon, but you can easily move them to a private cloud, or you can move them to other cloud providers. You lose that capability with functions as a service. And functions as a service ultimately provide a different capability. Now, what we're talking about doing, though, in CloudOne is figuring out a way to expose function as a service, whether it's Lambda or Fargate or Azure functions, to our developers through the CloudOne interface. So they would have the option of doing DevOps, which I showed today, which is custom application development using containerized applications. They have infrastructure as a service, just get some VMs and storage. And in the future, we would expose functions as a service through the same catalog we have for CloudOne, so developers can take advantage of those capabilities if that fits their application architecture. Okay, was that the only question in there I saw?
The only one I see.
Yep. See another thing pop up. Yep. Thank you. Perfect, thanks. Okay, what I'm going to do now is going to talk about, I'm going to show do the demonstration of CloudOne. I do the demonstration through slides just because it's more efficient. the demonstration is done from the developer experience perspective, because as we talked about, CloudOne is ultimately a development platform for cloud-aware applications, so we're servicing developers. To do the demonstration, though, we actually had to build our own application. It's very hard to demonstrate a development platform without an actual application. So we built our own application as we used to demonstrate the CloudOne platform. This application we built is a URL shortening tool. We call it tinyURL. And it's things like Bitly, and Google has one where you take a long URL and you shorten it to something more manageable. This is the production screenshot of the tinyURL tool. And to demonstrate CloudOne, what we're going to do is we have an app feature request. If you notice right here, it says 4 to 14 characters. So your tiny URL could go up to 14 characters. And the app feature request is saying, well, 14 characters isn't really that tiny. Can you reduce the max character length from 14 to 8 to really make the URL tiny? So that's the feature request. And now we're going to use CloudOne to ultimately make that change to our application. So the first thing we need to do is run the day one automation where we onboard this application onto our platform. So in ServiceNow, you can see up there at the top is the URL for ServiceNow. We go to our enterprise service portal, and the enterprise service portal services all sorts of employee needs, whether it's submitting a ticket to the help desk, getting help through approvals, or ordering something like ordering a PC, ordering new software for your computer, those type of things. We also can order our CloudOne services. So inside that portal, on the service catalog, we have CloudOne and CloudOne DevOps. And in this case, I'm going to onboard an application onto CloudOne. So when I go to onboard an application in CloudOne, I first need to build my workspace by choosing the application from a drop-down list. And this is important because this self-service portal is in ServiceNow, which is also our CMDB. So that application has to be registered in the CMDB to be onboarded onto CloudOne. That allows us to keep track of all the assets we're going to create through this automation. So I select the application from the CMDB list, and I provide a cost center so we can show back charges. And then as the developer lead, I choose the size of my host space. I have a stage and a production host space environment. So I can choose a small, medium, or large CPU quota for both of my environments. After I choose the size of my host space, then I'm going to choose the application stacks or the microservices that I'm going to use to build my application. So in this case, first I need an API service. I'm going to use Spring Boot. Then I need another API service. I'm going to use OpenResty. And then finally, I need a web server, and I'm going to use React.js to build that web service. So now I've chosen the application stacks, which I'm going to build the application on. And now I hit submit. When I click submit, then the day one automation begins, where ServiceNow updates the CMDB, then hands to CloudForms, which invokes the Ansible automation. The first step in day one, though, is to update the configuration management database for this application. As you can see in the URL at the top there, it's still ServiceNow. This is the screenshot of the CMDB entry in ServiceNow for the application NetApp tinyURL. If we look inside this entry for tinyURL, we can see that the day one automation has been tracked. We track the microservices. There's the two API and the services we created, the stage and production environments for the host space, and then we actually create a data spaces also, and I'll show that coming up. So we have two database environments. And then finally the workspace, which is the non-production part. If we look inside the workspace entry for this application, we can see the actual links to the different platform components for this application. So the OpenShift project, VSTS is actually another name for Azure DevOps. So there's the Azure DevOps environment, and then the Artifactory environment that does all the binary and container management. On the right-hand side are the email lists. So NG is NetApp Group, and then the different email lists that we create to do the role-based authorization in this application. So we track all of these assets, again, physical and logical assets for this application in the CMDB. Okay. At the end of day one automation, the user, the developer lead, or whoever started the workflow is going to get an email from ServiceNow saying your workspaces and host space has been created, and here are the links to the different environments that have been created for your application. Okay. Now in this case, I'm also going to add other capabilities. So I've onboarded the application, but I needed some other capability. So I'm going to go back to the service catalog in ServiceNow, and I'm going to manage CloudOne DevOps application. So now I'm going to manage my application. I still choose tinyURL. I've already got my host space created, so there's my production and stage environments. But now I'm going to add a database. So using data spaces, I'm going to add a Redis database with a 50 gig size. And then I also decided I needed another application stack for my application. I needed a proxy service, and I'm going to use Nginx as the application stack to build this proxy service. And then I'm going to submit. And now the day one automation will rerun, adding the databases to this application and adding the Nginx application stack to the application. If you think of, remember the day one automation slide, there were 4 major routines that we run. The first of those 4 is configuring the Artifactory environment for the binary management for the application. So if we go in the JFrog Artifactory interface, we can look through the repository browser and find TNY, which is the 3-letter code for tinyURL. And then we can see some of the binaries that are being tracked by Artifactory for this application. The second thing we did in day one automation is we used our internal tool called Neat to create some email lists so we could do role-based authorization. This is a screenshot of the Neat tool, and these are the email lists that get created for the TNY application: admin, biz, dev, leads, and ops. And each of those email lists have different people in those lists, and then those lists are used to do the role-based authorization through the platform. This right here is an example of the admin group for TNY application, and you can see I'm an admin of the TNY application, so I can do anything to the application. Other people, though, who maybe only are dev, they could submit code changes, but they can't approve those code changes all the way to production. Okay. If the third step in day one automation was configuring OpenShift. So now we can look in OpenShift, and here's NetApp tinyURL, TNY, and the workspace. So here's the workspace and some different environments that are running in the workspace. You notice right here there's links, and these are the links to different instances of the application running in non-production. So remember I mentioned we run the day 2 build process where we create a binary in 5 minutes and deploy that binary. Developers can then click on this link and see their application changes running in non-production. In OpenShift, now we also have the production side. So this is the host space. And you can see here's the proxy part of tinyURL running in production through one pod. And there's the link to the production URL for tinyURL. And then finally, we have the databases. We added a database as a service to this application. We added a Redis database. So in OpenShift, here's the database as a service for production. And you can see it's running one pod. And since all databases receive a cloud volume, here is the storage for that database as a service that's bound to a cloud volume. And then finally, in day one, we configure Azure DevOps for the application. And Azure DevOps is the primary developer ecosystem for working on applications. So here's the login for Azure DevOps. And since my login, I'm an admin of the TNY application, tinyURL, the TNY workspace has been published to my login into Azure DevOps. And if I look inside Azure DevOps for this application, you can see the different service connections to other parts of the CloudOne platform. So the links to the database service, on the different components of OpenShift, and the links we have to Sonar Cube and other tools that will be part of the build process. So this is how we verify the integrations have all been created in Azure DevOps to the other parts of the platform. Okay. So that's the end of day one. Notice we haven't made any changes to the application yet. We simply onboarded it on the CloudOne. We ran through the self-service catalog. We selected the application stacks and the size of the workspace. We submitted the workflow. It configured OpenShift. It configured Artifactory. It configured Azure DevOps. Our application has now been onboarded on the CloudOne. Now I can go to day two, where I can actually make changes to the production application. And as a developer, I'm going to use Azure DevOps to make those changes to my application, as Azure DevOps is the primary developer ecosystem in CloudOne. So again, my login in Azure DevOps, I'm an admin for TNY Workspace, so I can go into TNY Workspace. The nice thing about Azure DevOps is it's more than just a DevOps tool. It's a full application lifecycle management software. Microsoft uses Azure DevOps to create their own products. So Windows, Office, Xbox are all coded by Microsoft engineers using Azure DevOps. So we use Azure DevOps for our own application development. In this case, I'm going to work on TNY Workspace. As a developer, I'm going to create a user story to track my work. And the user story was, remember, the feature request of reducing the length of the tiny URL from 14 to 8 characters. So I've created a user story, I've named it, and I've put a short description in of what I'm actually going to do with this user story. Once I've created the user story, then I can create a source code branch. So as a developer, I never want to edit the master source code branch because that's the golden image of the source code. So what I'm going to do is I'm going to create a feature branch of the master, and then I'm going to make my code changes to the feature branch. And I'm going to name this feature branch reduce because my user story was reduce the length of the tiny URL from 14 to 8 characters. So I name my branch of the source code reduce. Once I create the branch, then I can clone the repository into a integrated development environment, a code environment on my computer. So a lot of developers like to use their own IDE. They have certain love for different IDEs they like to use. That's fine. As long as it's Git compliant, Azure DevOps can clone the source code branch to their local IDE. So when I click on clone, then in my PC, VS Code is going to open up. And VS Code is a software editing tool from Microsoft. VS Code opens up and it says, do I want to open this URL, which is the link in Azure DevOps to my source code branch. I click open, and then I'm going to find in the source code the max length parameter for the tiny URL. And instead of being 14 characters, I'm going to change that from 14 to 8. A small change, not a big change, keeping with our CloudOne principles, make small changes to source code to reduce the risk. And now I'm going to submit my code change to propagate it to production. So I change it to 8 characters. Then I do a commit to the source code repository. And in Azure DevOps, I'll do a pull request. And this pull request essentially pulls my change into a release branch. When I do the pull request, that kicks off the the CI automation. And the CI automation is going to combine my source code branch with one of those application stacks and run a build process. And that build process, again, takes about 5 minutes. And it's going to create a binary. And it goes through a series of steps, though, to create that binary. Everything from looking at the product catalog to running a sonar scan to doing security checks and actually aligning to the Helm chart. As you go through the build process in Azure DevOps, you can see through a console logs everything going on. So here in this case, there's the X-ray scan. X-ray is a part of JFrog that does security scanning. So we're scanning the source code and the binary as we build it for any vulnerabilities. At the end of the build process, again, takes about 5 minutes. We can see the success. There were a few notifications during the build, but nothing that failed the build. One of those things that we notified there was X-ray scan. There was a notification. So we can go into X-ray and look at this actual build process and see that we had a medium security notice. We can look at this medium security notice and see that we had a Red Hat security advisory for this build. Nothing critical that would fail the build. Any security critical notifications fail builds, but it's medium, so we allow the build to continue, but it's something we need to track in the future to fix. Now that I've completed the CI process, I'm now into the delivery pipeline. And you notice there, the delivery pipeline is ultimately a release and a release ultimately to production, but I'm only in the workspace part. If I look at the workspace of the release process, notice it says resume, and it says pending intervention. What that means is it's pending intervention by the developer because now the build process is run and the containers have been deployed into AWS, and now the release is just waiting. It's waiting for the developer to go do the developer stuff. I need to go play with my application, look at the source code changes, those type of things. So now I can go into OpenShift and look at the workspace. Again, the workspace is the non-production part of the application, and I can see my reduce. Remember, I named my source code branch reduce. So I have reduce running in one pod, and there's the link to my changes of the application running in non-production. And when I click on that link, I can see the application running in non-production with my changes. There's the 8-character length. And as a developer, I'm going to play with it a little bit. I find a new link and I test it out, and now I can see I can go up to 8 characters no longer. So I've made my source code change. It's deployed it to non-production in 5 minutes. I can go to the link and I can play with it, and I'm happy with my change. Now that I'm happy with my change, I'm going to go back to Azure DevOps in the release pipeline, and I'm going to click resume. So now I'm saying as a developer, I'm happy with the results in the workspace. Resume the release process. Resume the CI/CD process. When I click resume, you notice in the workspace, the first thing that happens is Helm delete. So since the workspace is no longer needed, we are cleaning it up by deleting it. We are removing those containers that got deployed and freeing up resources in AWS, which ultimately lower our costs in AWS. If we look inside OpenShift in the workspace again, you'll notice that my admin reduce is gone. So there's other instances of workspace, other developers doing work in the workspace, but my change of admin reduce has been cleaned up. It's no longer running in the workspace. Now we get into stage environment. So this is where we deploy the containers into stage in the private cloud, and then we pause one more time to allow people to do testing, like load and performance testing, UAT testing, and so on. Once that's done, we approve from the stage environment, and that gets us to production approvals. This is the final step before we make changes to the production application. When a production change is ready to be released, people in the TNY production group, or TNY ops group, receive an email saying that a production change is waiting your approval. And we'd like you to log into Azure DevOps to review that change and approve that change to production. So when I go back to Azure DevOps and I click approve to this production application to verify it's me and someone else is not making an unauthorized change to a production application, it asks me to log back in again. And to be doubly sure no one can change our production applications, it requires me to two-factor authenticate. Once I two-factor authenticate, then the automation starts. We download the binaries from JFrog Artifactory into the production environment, and now the production application has been updated with the change I've made. And now I can go to the production URL. There's the production URL for this application, and my change has been propagated to production, only 8-character length. Okay, well, thank you, everyone. I hope this was very helpful today, and hopefully turn to NetApp for future capabilities around DevOps and automation and cloud. Thank you for the time.
Thank you very much, Mike. That was really, really good. I really enjoyed that. I need to watch the video again, I think, to go around. It's amazing how much goes on that we don't know about. Again, thank you very much. That was very, how can I put it, educative. And I think it's useful for our partners to understand what we do internally as well. So have a good day. Yeah. And
thank you, everyone. Have a good day. Happy Friday.